Hey, welcome back to this lesson. We've done 2 lessons already about how to solve log equations. So as a reminder, to solve log equations, you must condense to a single log applying the properties of log, such as the product, the quotient, and the power. And then once you've condensed to a single log, then you convert to exponential. You convert the equation to exponential, and once you've done that, then you solve. Okay. Also remember that we cannot take the log of negative numbers or the log of 0, and I've explained that on the previous lessons. And just as a recap for quadratics, when you solve a quadratic equation, you always set it equal to 0, or you factor it out and you set each factor equal to 0, and then you solve. Okay, so for example, if I have x squared minus 4 equals 0, I would add 4, so then add 4 to both sides of the equation, so then we have x squared equals 4, but then you take the square root, and the square root of x is going to give you the absolute value of x, and the square root of 4 is going to give you 2. So when you remove the absolute value, that gives you plus or minus 2. But keep in mind again, the negative 2 will not be a solution because we cannot have a negative number with logs, okay, as a solution. So I'm going to go over these examples. I'm going to do this column. It's already done, but I'm going to explain the steps that I've taken. So for example, here we have a power. So I'm going to apply the power to x. So x is going to become x squared. And then I'll condense into a single log in the second step. Okay, so step 1, apply the power rule. So this becomes x squared, and this stays as log base 3 of 3. So then what I'm going to do next is I'm going to condense to a single log. So we have log base 3 of 3x squared equals 3. Now, from this step, we go to converting to exponential because it's one single log. So the base of the log times raised to this power is going to be equal to 3x squared. So we have 3x squared equals 3 cubed, but 3 cubed is equal to 27, right? So once we get this, then we're trying to get the x squared by itself. We divide by 3. So then when you divide 27 by 3, that gives you a 9. So we have x squared equals 9. We want x, not x squared, so then we take the square root of both sides of the equation. So that gives us the absolute value of x is equal to square root of 9, which is 3. But when we remove the absolute value, we have x equals plus or minus 3. But then don't forget, we cannot have the negative solution because those values are not in the domain of the log function. Okay, so the only solution in this case is x equals 3. All right, next problem. So for this one here, we have 2 logs again. And notice we have log base 12 of x plus log base 12 of x plus 1 equals 1. So let's condense to a single log by applying the product rule. So then this condenses to a single log. So we have log base 12 of x times x plus 1 equals 1. But then I'm going to distribute this x to this x plus 1. So once we distribute, it becomes log base 12 of x squared plus x equals 1. So then once we have done this, we convert to an exponential equation. So then 12 to the first power equals x squared plus x. So now we are here, right? So then this becomes x squared plus x equals 12. So then, because 12 to the first is 12, so that means then we bring this 12 to this side, so we have a 0 on this side of the equation. So then we have that x squared plus x minus 12 equals 0. So we're back to factoring. We need to find the multiples of a times c, a being 1 and c being negative 12. Multiples of negative 12 that when you add them, give you a positive 1. And the only multiples that do that are negative 3 and 4, because when you multiply, negative 3 times 4 is negative 12, and negative 3 plus 4 gives you 1. So then when we factor it out, this is what we have. So one linear factor is x minus 3 equals x minus 3 times x plus 4 equals 0. So then we set each factor equal to 0, and then we solve. So x minus 3 equals 0, x plus 4 equals 0. And then when you solve for x here, you add 3. So then we have this solution. And when you solve for x here, you subtract 4. So then x equals negative 4. But again, we cannot have negative numbers as solutions. So then this is extraneous. Okay. So with that said, let's go on to example number 3. And this one is, I'm going to go over this one along with you because this one will be a little bit more involved. So notice that we have a 2 in front of this log. So this means we have to apply the power rule. Okay, so I'm going to do that first. I'm not going to condense to a single log yet. I'll get to that part in a moment. So this becomes x plus 3, applying the power square. Now notice I'm also going to move this log to the other side, which means it's positive on this side becomes minus on this side. So minus log base 12 of the number 4 equals 2. Then now we are ready to condense to a single log. So condense to a single log, in this case we're going to apply the quotient rule, okay? So log base 2 of, and I'm going to pause here because I'm going to take this to the side and I'm going to expand it. So I'm going to pause the video, expand it, and then I'll come back to it. Okay, so when I take this to the side, x plus 3 squared means we have 2 of those binomials. So when I multiply x times x, that gives me x squared. X times 3, that's 3x. And then 3 times x, that's another 3x's. So those x's combine to 6x. And then last I multiplied 3 times 3, which gives me a 9. So then that goes on top of the on the numerator. So we have x squared plus 6x plus 9. And then in the denominator, we have the 4. And this is equal to 2, right? Now we are ready to take the inverse of the log. So take the base of the log, raise it to the power of 2, and set that equal to this expression. So we have x squared plus 6x plus 9 over 4 is equal to 2 squared. So 2 squared, we know 2 squared is equal to 4. So then we have x squared plus 6x plus 9 over 4 is equal to 4. Then I'm going to write a 1 under that 4 so I can cross multiply. So when I cross multiply, on this side I get 4 times 4, which is 16. And then 1 times x squared plus 6x plus 1 is just x squared plus 6x plus 9. Then I need to get a 0 on this side, so I'm going to subtract the 16 from both sides of the equation. So then this becomes x squared plus 6x, and 9 minus 16, that's a minus 7, and that equals 0. So now we need to find the multiples of a is 1, c is negative 7. This is going back to the lessons on quadratics, so multiples of negative 7, 7 being prime, this shouldn't be a hard one to do. That add to a b value of 6. So it's obviously going to be 1 times 7, but we need a positive 6 and a negative 7 when we multiply them, so then the 1 has to be negative. So when I factor this out, we have x minus 1 times x plus 7 is equal to 0. Setting each factor equal to 0, we find, okay, so let me not jump the gun here. So x minus 1 equals 0, and x plus 7 equals 0, which means for this one you add 1. So then x equals 1, and for this one you subtract 7, so x equals negative 7. And again, we can't use negative values, so that means the only solution we can use is x equals 1. Okay, so that's example number 3. Last example. In this case, you don't have logs, but the purpose of this example is just so that you remember factoring by grouping. Okay, so what I need to do is I need to find multiples of a times c. In this case, a is not 1, a is 3. So multiples of 3 times negative 4, which is negative 12. But then those multiples need to add to a b value of positive 1 because we have 1x as a b value. So then what I need to do is find those multiples. And the only multiples that do this are negative 3 times positive 4. All right, because negative 3 times 4 gives you negative 12. Negative 3 plus 4 gives you 1. So then I'm going to split up x into negative 3x plus 4x. Okay, so again, this is your review, just review, because we've done this during the first semester of Algebra 2. So 3x squared, I'm going to group the negative 3x with the 3x squared, so minus 3x, and then plus 4x minus 4 equals 0. So then from here, we factor by grouping. So we find a GCF of these two terms, and the GCF is 3x, and then find a GCF of these two terms, and the GCF is 4 itself. So then we have a GCF of 3x, and then now this becomes x minus 1, and then plus the GCF of this group, which is 4, and then you're dividing by 4, so then this is x, and this becomes minus 1. And now I'm going to put 3x together with 3x plus 4, with plus 4, positive 4, so then 3x plus 4, and then x minus 1, and now we are ready to solve. So first we have 3x plus 4 equals 0, and the other is x minus 1 equals 0. This one you would subtract 4, so we have 3x equals negative 4, then divide by 3. So one solution is x equals negative 4 thirds, and for this one you just add 1, right? So then the other solution is x equals 1. But again, this is negative, so we cannot use this solution. We can only use this one, okay? Because again, this is logs. In general, I mean, you could, if this was just a quadratic, you could. But we're working with logs, so we cannot use the negative solutions. And that is all for this lesson. I'll see you in class. Bye-bye.